see the slides? Okay, thank you. So, hi everyone. I'm Rohit Kumar Singh, and this is our first live session for this course, Experimental Physics 2, and it is being taught by Professor Amal Kumar Das over NPTEL, and I'll be the teaching assistant. And in this live session, we will try to recap the concepts that has been discussed in the weekly lectures on NPTEL, and we'll try to also solve some sample problems to help you with the tutorial assignments. And in general, you can ask any doubt and anything that you want to uh, ask me. Okay, so yeah, feel free. Uh, some basic things. So yeah, this live session which I will conduct, it will run from 3 to 5 p.m. on Saturdays. Okay, and this is the Gmeet link. Uh, this is the Gmeet link, and this is the YouTube channel which where you can find all the recorded sessions. So this all things will be recorded and you can find there. Also, you can find this slide also here in this Google Drive folder. Okay, for reference. Okay, anyone has any question? Okay, I guess no. So okay, so all of you have registered for this course, right? And did you go through the first week of lectures, or uh, you are planning to do this by next week? Or you all have okay, gone through. Uh, did all have gone through, or someone has not? Okay, I mean, just to know, like, did you refresh all the formulas and all the concepts, or do I need to explain you a little bit more? So I'll assume for now that you all have gone through the lectures. So then what I'll do is I'll start with some simple problems, okay? And yeah, let's try to solve them. You can also unmute and ask any dot at any time, and you can also try to answer it, okay? So don't hesitate. Okay, so let's start. Okay, so this is a very simple problem. Uh, a simple pendulum of length 60 centimeter is taken inside a deep mine. Okay, assume for the time being that the mine is 1600 kilometer deep. Okay, and calculate the time period of the pendulum there. So you have to calculate the time period of the pendulum when it is taken 1600 kilometer deep inside the mine. Okay, and the radius is given here, which is 6400 kilometer. uh, so the radius, this is the radius of the earth. Okay, and the value of g, which is acceleration due to gravity, on the Earth's surface, as you know, is 9.8 meter per second square. Okay, so these informations you have. Now, based on this, you have to calculate the uh, time period of the pendulum inside the mine. Okay, so anyone know how to do this? So basically, you have, oh, sorry. So suppose this is the Earth, and you went 1600 kilometer deep inside. Okay, and at this point you want to calculate the time period. Okay, so suppose, and okay, so suppose this is the radius of the Earth, r, and this is the distance d. Okay, so like this. So do you know how to do this? Anyone? So let me first ask. So all of you are in either BSc or MSc, right? I think I'll assume most of you are in BSc, right? Or bachelor's in engineering or somewhere. Can you please tell me what in what course are you studying right now, so that I'll get an idea what level of understanding you have. So I'll start with Vetri Selvi Parshuram. So Parshuraman, can you tell me what are you studying? Hello, MSc Physics. Okay, and then so you must be knowing all of these, right? BSc Physics. Okay. Anyone else? Yeah, for MSc people, this will be very simple, but it's a good exercise to, recap everything. So, anyone else? Arpit, what are you studying? MSc completed. Okay. Then Mahalakshmi, MSc Physics. Okay. Umar, Umar Farooq. Okay, so so all of you are from physics background, right? And so yeah, I'll assume that you know all of this, so I'll go over it quickly. Okay, Alekhya also MSc Physics. Okay, nice. So you must remember there is this formula that the acceleration due to gravity depends on the distance, depends on where you are measuring it on Earth. Okay, so this is a formula. What it says is, so if you take if you go at different height or depths on Earth, you will find different acceleration due to gravity. Okay, due to the uneven shape of the Earth. Earth is not symmetrical everywhere, right? So, so this is the formula. When you go d distance inside the Earth, the acceleration due to gravity changes like this. Okay, so basically, so here what we and it depends on the distance d, uh, at what depth you are, and the radius of the Earth r. Okay, and g is your standard acceleration due to gravity. So here in this case, d is what, 1600 kilometer, right? R is what, 6400 kilometer. Sorry. And then g is 9.8 meter per second square. Now I'm not deriving this formula. This formula is very famous, and I think this is derived in the lectures. And if not, you can find any class 12th physics book with gravity chapter, and there you can find the derivation of this formula. Okay. So if I put everything in this formula, I will find the g at distance d, which will be, so I'll take the g common from here, so 1 minus d by r, and then 1 minus 1600 and 6400. So this you will get 3 by 4. So what it says is the acceleration due to gravity at distance at the depth d, which is 1600 kilometer, will be 3/4 of what you get on the surface. Okay, so the value of g has reduced as we expect, right? Because intuitively you can see at this depth you you encounter a small Earth. You can as you can see, the radius of the Earth that you encounter at that depth is small. So the mass that the mass of the Earth above that depth will not affect uh, on the acceleration due to gravity, will not affect you basically. So intuitively you can think about like this. Okay, now you have to calculate the time period. So what is the time period of a pendulum? Can anyone tell me? What is the formula of time period of pendulum? Guys, anyone? Suppose you have a pendulum. Suppose you have a pendulum of length L, okay, which is oscillating like this. So what will be the time period of this pendulum? 2 pi under square root L by G. Yeah, nice. You guys can speak up. There is no problem. So because now uh, the G has changed, we will put GD instead of G. Okay, and the new G we have is 3 by 4th of uh, the standard G, so 2 pi L 3 by 4 of G. And if you put everything, so L is given, as you can see, L is 60 centimeter. You should convert it into meters. And what else is given? G is, 2 pi, So if you put everything, you will get an answer, which I'm going to just write 1.795 seconds. Okay. Okay. So this is the simple problem. So anyone has any doubt here? Anyone would like to ask anything? No? Okay, fine. Uh, okay, thank you. So now we'll go to our next problem. So here again we have a simple pendulum, but this time what we have here is, so there is a simple pendulum of mass 0.2 gram. So this is, as you can see, very light pendulum. Okay, and its length is 50 centimeter. Okay, so this is the length, 50 centimeter. Okay, and it is displaced through an angle of 20 degrees. So let's displace it by an angle 20-degree. Okay, and then released, and then we release it. Okay, so the question is, what is the maximum speed of the pendulum? Okay, again G is given. So yeah, you have to calculate maximum speed. Now how do you do that? First of all, let me know where will be the maximum speed. At what position will be there? Will the pendulum has maximum speed? Anyone? Is it here? So is it position 1, position 2, or let's say when the pendulum comes on the extreme left, position 3? Where do you think the pendulum will have maximum speed? Anyone? Can you hear me? Hello? Arpit? What do you think? This is a simple question. Position 2, yeah. Okay. So we know that at position 2, the pendulum will have maximum speed, right? So Now, how to calculate the speed at point 2? Do you know what we can use here? What principle of physics we can use here? How can we calculate it? Guys, anyone? Simple problem. This is a class 12th level physics, right? 11th and 12th level physics. So it should be very easy for you guys. So please answer quickly. How can we do this? Conservation of energy, Arpit says. Anyone else? Yeah, I mean, Arpit is right. So we have to use the concept, the very basic concept of physics, which is conservation of energy, right? So how do we do that? So first, so at this point, okay, sorry, yeah, when the pendulum is at when we displace the pendulum, what did we do? We gave some potential energy to this pendulum, right? Some potential energy U, and when we released it, this potential energy got converted into the kinetic energy. Okay, so what potential energy did we give? So we gave it mgh. Okay, this is the formula for potential energy. Whatever the mass of the pendulum is, whatever the g is, it is fixed, but the height that we have gave it, so when we raised it by 20 degree, this height that got changed, this height, let's call it a small h. Okay, this height is the this height gives this pendulum its potential energy. How if you displace it through much more degree of angle, then this h will increase. Okay, and then this kinetic energy get converted into potential. This potential energy got converted into kinetic energy, which is given by half mv square, and v is the velocity. So if we calculate at point 2 kinetic energy, okay, uh, you will know that so this all of this potential energy get converted into kinetic energy at point 2, right? Because the height is 0 here, so no potential energy is there at point 2. So I'll write it here. So at point 1, so this was our point 1, what we have, kinetic energy is 0 and u is mgh. At point 2, kinetic energy is half mv square and u is 0, right? So what happened, u is converted into k. Now we have to find first what is h, right? We know m, we know g, but we don't know h. But we know the degree of angle the pendulum got displaced by. Okay, so we can use simple trigonometry. So what you can do is, so this is the length L, right? The length of the pendulum, and this is length L, and suppose this is the length H. Okay, you see now H by L, what it will be? Is it cos 20 degree or sine 20 degree? Anyone? So this is 20 degree and this is also 20 degree, this angle. So it will be cos 20 degree, right? H by L, the ratio of H by L. And so you can calculate H is equal to L cos 20 degree. Now, this L is equal to small h plus big H, right? This total distance is equal to L. So you can put here, so basically you can write this as H equal to, or okay, wait. Yeah, you can write this as L minus L cos 20 degree, right? We have just replaced the big H by L and H, which is H is equal to L minus H, right? And so you can calculate the small h, which will be L1 minus cos 20 degree. L is 50 centimeter given, and you will get 0.03 meter. Okay, you can put the value of cos 20 here using calculator or anything. Okay, so now we have H. So just we will use the conservation of energy. Conservation of energy. Okay, so mgh equal to half mb square, and we want to find the velocity v, right? So v is equal to, so you will see that get cancelled, and v is just simply under root 2gh, and if you put everything you will get 0.767 meter per second. Okay, anyone has any problem here, any doubt? The simple problem, right? Just these are just, refresh your memories. Maybe you have forgotten all this, but these are very simple things. Okay, so everything clear? Guys, please respond. You, yeah, thank you. Others also please respond. You can unmute and speak. This live session is interactive session. So here we supposed to talk to each other, right? So you can, don't hesitate in any language that you want to speak. You can speak, and I'll try to talk. Okay. Okay. And so let's go to the next problem. Now this problem is related to SHM. Okay, simple harmonic motion. Everyone know what SHM is? Anyone can explain what SHM means? In simple terms, when do we say an object is performing SHM? I mean the equation of motion of SHM. What is this? What is it? No one? Example of clock. Clock is not doing SHM. You can take a spring, and place a ball on the spring, then that will perform SHM, oscillating from one position to another. Yeah, it's a very simple definition, but okay, so let me write first what SHM means. So in SHM, the position which is given by X, position of an object should move like this. Okay, it should have a uh, periodic change with respect to time. Okay, that means, so what does it mean? So suppose you have there is a spring, there is a box attached to the spring, and let's assume there is no friction. So once you release this, suppose this is its rest position, you release it till here, okay, which is its amplitude A, and then you release it. I mean, you extended it and you released it from a distance A. Then it will follow this equation. Okay, its position as a function of time. It will follow this equation. How? Because you see, when you released it at 0, at t equal to 0, what is the distance? It is at x equal to a, right? You released it here, and then after some time it will go here, right, which is minus a, and it will stop. And so at which time it will go here? It will go at some time when the sine wt is -1. Okay, so and then it will again come back and go. So it will oscillate, it will keep oscillating. So at time equal to sine inverse a by omega x equal to minus a, right? Sorry, uh 2a, because this is the 2. So you get the idea what SHM is, right? Now the question, what question says is, uh, you have to so the magnitude of maximum velocity and maximum acceleration of particle executing SHM are equal. The time period of the SHM. So you have given a condition uh, where the maximum velocity and maximum acceleration of a particle, so suppose this box, executing SHM are equal. So then you have to find the time period of the SHM. Okay. So you have the formula for the position of the particle which is performing SHM. Now to find the velocity, what you can do is you can just differentiate it with respect to time, right? This is the velocity. What do you get? A omega, and sine is, differentiation of sine is cos. Correct? Everyone knows how differentiation is being done, or anyone has any doubt? And so we need maximum velocity. So V max. Now, what will be the maximum value of this thing? So A and omega are fixed, right? Omega is the frequency and A is the amplitude. So these two we cannot change, but the cos omega t, so the time, yeah, right. So cos omega t varies from -1 to 1. So the maximum will be when cos omega t is 1. So V max is AW. Okay. Now we need the maximum acceleration also. So for acceleration, we will differentiate it once more. So d square x by dt square, and when we again differentiate it, cos omega, cos, cos theta goes to minus sine theta when we differentiate it. So minus a, and this constant will come outside, so multiplied by omega, it will be omega square and sine omega t. So this will be the acceleration, and again acceleration will be maximum when sine omega t is 1. So what is the maximum acceleration? Minus a omega square. Okay. And now we have maximum velocity and maximum acceleration, and it is said that their magnitude are equal. So let's equate them. So for magnitude we don't need the negative sign, so we'll just take the magnitude. Okay. And omega cancels omega, a cancels is, so omega equal to 1. This is what we got. And what is omega? So how can we find the time period of a system? Anyone remember what is the frequency? What is the relation between frequency and time period? Yeah, 2 pi by t equal to 1. So we have time period equal to 2 pi. Okay, this is a very simple problem again. Anyone has any doubt here? Okay, if not, then let's move to the next problem. Okay, so here instead of SHM, we have a traveling wave. Okay. So what is a wave? What is a wave? Anyone can anyone tell me what is a traveling wave? Anyone can unmute and tell me what is a traveling wave? How how do you understand a wave? So okay, so it's not. Let me tell you. So if so, just now I wrote the equation for SHM, which was this. Okay, here there is a periodic motion with respect to time. Okay, of any particle. Now, what a wave represent is, so usually the wave is represented by this kind of, you know, graph. So suppose there is a point like this. Okay, so a traveling wave means this point will move with respect to time and with respect to position also. Okay, and its equation is given by, so suppose some amplitude a sine minus kj. Okay, so this is the z direction in which this wave is traveling. So this is the equation of a wave. Okay, so it will be so it's the position of all the points on a wave will keep changing according to this and it depends on time and the position z, and it is periodic. Okay, so this is the definition of a wave. Okay, but here the problem is a progressive wave of frequency one. So we have been given the frequency of the wave. The frequency is 180 hertz. Okay, and the velocity of the wave is 360 meter per second. So the velocity of wave means the velocity of all the points on the wave. Okay, change dz by dt, you can say simply. And how far apart? So the question is, how far apart are the 2 points 90-degree out of phase? Okay, so what does it mean is, so let's again draw the wave. Sorry, uh, it is not a good drawing. Let me try again. Okay, let's work with it. So suppose so what the question is saying is, we have to find, so there are 2 points on the wave, and we have to find the distance between the two point, the z distance, which are 90-degree out of phase. Okay, so let's suppose first point is here. Okay, and so the so where will be the next point for it to be 90-degree out of phase? Can anyone tell me? So there, I'll give you some options. First here, this is the one. Second here, third here. Anyone? Any clue? Where the second point need to be for it to be 90-degree out of phase? Is it at 1, 2, or 3? Can anyone respond? So let me give you a clue. So suppose if you start from this point, uh, the whole 360 degree will be covered when we reach at the same height and going in the same direction here, right? So this is the 360 degree. Starting here, this point will be 360 degree out of phase. Now where will be the 90 degree out of phase point? Anyone? It is at 1, right? 90, 180, 270, and then 360 again, right? So we have to find this distance, correct? How do we do that? Anyone has any idea? This is very simple. No? Okay, let me tell you. So we can find wavelength using these two quantities, because wavelength is given by velocity by frequency, right? Everyone knows this. So if we divide velocity by frequency, we get 2 meter. So this means that, and what is the wavelength? So wavelength is that distance where the point go where 2 points are 360 degree apart. Okay, so that is the wavelength. So this distance is the wavelength of this wave. Understood? And we have to find this distance, this. So, and this distance is what? This is just 1 by 4th of wavelength, right? So the correct answer is 0.45 meter. This is a very simple problem. Just you have to. Anyone any doubt here? Guys, please speak up. No one is responding. Arpit, did you understand? Okay. Mahalakshmi, is it okay? Okay, thank you. You guys should respond quickly, huh? So that I'll know that you guys are following. Okay, let's go to our next problem then. So here uh, we have a string 50 centimeter long. Okay, so you have a string which is 50 centimeter long, and its mass is 1 gram. Okay, and it says it produces a note frequency 100 hertz. Okay, so you all of you must have seen that when you take a string and you strike it, so like in a guitar, it produces a note, right? And it has some frequency. So suppose this is a guitar string, okay, 50 centimeter long, and you when you pluck it it produces some sound, right? And the frequency of the sound is 100 hertz. Okay, and it is given key this note is when it's vibrating in its fundamental mode. So a string can vibrate in different modes. So let me explain how. So when you pluck a string, it can either vibrate like this, right? Or it can vibrate like this, or more, you know, like this. So these are different modes of vibration. Okay, and the fundamental mode is which? So this is the fundamental mode of vibration of a string. Okay, it's it is given by n equal to 1. N equal to 2 is the second harmonic, and so on. You must have studied it in when you studied waves in your class 12th or somewhere. Okay, so we have to find the tension in the string when it is vibrating uh, at a frequency of 100 hertz in its fundamental mode. Okay, so 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 let me just write the formula of frequency. So frequency of vibrating string is given by 1 by 2L T by rho. What is this rho? Anyone? This is the tension in the string. Okay. And what is the rho? Linear density. Yeah, right. M by L. Okay. Sorry. M by L. Okay. So, so from here you can so we want to find the tension in the string, so we can just take T out, okay, which and which will give us 2L R square, oh sorry, F square. F is the frequency into M by L, right? And here L get cancelled, and you can put all the values, and it will be 20 Newton, which is the tension. Okay. It's a simple exercise just to remind you of this formula. I hope it's clear. Okay, now let's move to the next problem. Again, it's a very simple problem. So what it says, if the compression in a spring becomes double, then the potential energy is increased by what factor? So will there be no change? Will it be 2 times, 3 times, or 4 times? So anyone, please guess what will be the answer is. Alekhya, Arpit says 2 times. Anyone else? Everyone should answer. Okay. Alekhya also says 2 times. Omar, what do you think? Mahalakshmi also says 2. Yeah, because you see, it's very simple, right? If you have a string, what is the potential energy of stored in a string? It is k. Oh, sorry, it is kx square, right? And if the compression which is given by x, it gets doubled, then it's 2x square. So oops. So it will be 4 times half kx square, right? So it will be 4, not 2. Okay, is it fine? Again, just to remind you of the formula. This is the formula for potential energy in a string, in a spring. Okay, then let's go to our next problem. So, this is a problem on measurement. Okay, so all of you know what vernier calipers are. Vernier caliper, screw gauge, micrometers. Do you know everyone? These things are also taught in class 11, 12, and also in BSc practical labs. So I'll assume that all of you are familiar. So, so here the question is, for a given vernier caliper, the main scale division is 1 mm. Okay, it has 20 equal divisions on the vernier scale, which matches with the 16 main scale divisions. Okay, so you have to find the least count for this vernier scale. So anyone know the formula for least count, and what does the least count mean? Can anyone let me know? Minimum value which can be measured. Okay. Mhm. So Bimali, uh, shall I call you Vimal? So Vimal says the formula is 1 MSD minus 1 VSD. Okay, let me just write it. So least count is 1 MSD minus 1 VSD. So what is MSD? MSD is the main scale division and VSD is the vernier scale division, right? Now, what is the main scale division here? It is given, right? It is just 1 mm. So 1 mm. And but what is the vernier scale division? It is not given, right? How do you find it? Anyone? So Vimal, can you unmute and answer? What is, how can you find the vernier scale division? Hello? 10 divisions. How? Alakhya says 10 divisions. Can you unmute and explain how do you say it's 10? So okay, so if no one is responding, let me explain what does it mean. So here it says that 20 equal divisions on the vernier scale matches with 16 main scale divisions. Okay, that is, so suppose I'll draw the, yeah, list value of for one. Okay, let me explain. So this is, suppose this is the main scale. Okay, here you have some markings like this, and suppose this is 5 divisions between each marking, and then you have a vernier scale like this. Okay, over where you have 20 divisions, right? Yeah, and what the question says is this 20 divisions matches with 16 main scale divisions. Okay, so that means 20 divisions, 20 vernier scale division is equal to 16 main scale divisions. This is what is given, right? So one vernier scale division is what? 16 by 20 main scale divisions, right? And what one main scale division correspond to? It correspond to 1 mm, right? So 16 by 20 into 1 mm. So this is just 4 by 20 mm. Oh, sorry, what I'm doing. 4 by 5 mm, right? And the least count will be, yeah, you're right. Least count will be just 1 minus 4 by 5, which is 1 by 5, 0.2 mm. Okay, that's easy. Fine. So this is how the vernier scale division you can calculate. Okay, let's move to our next problem. So this is a problem based on screw gauge, which is another kind of measurement device. Uh, So first let me know, why do we use these devices? Why cannot we use simple scale? Why we need these kind of measurement devices? Accurate value. Yeah, not accurate. You can say more precise value, right? It increases the precision of measurement. You can get, yeah, you can get a precision in terms of, micrometers, which will be unachievable with the simple scale. So that's why we use these measurement devices. Okay, so here the question is, a screw gauge gives the following reading when used to measure the diameter of a wire. Yeah, yeah. You will get all these slides. Uh, I mentioned in my first slide that this you can. Okay, I'll put this link in the chat so that you can. Uh, Let me. Okay. Let me first finish it. Then after the lecture, I will put all these links in the chat so that you can open it. Okay, fine. And these all the slides will be available on this Google folder. Okay, thank you. So yeah, like I was saying, so this the problem is there is a screw gauge, uh, and we are using it to measure the diameter of a wire. Okay, and the main scale reading is 2 mm, and the circular scale reading. So the screw gauge has a main scale which is linear, and then there is a circular scale. Okay, which has some division. So here in this case, the circular scale reading is 45 divisions. Okay, and then there is information that given that 1 mm on main scale correspond to 100 divisions of the circular scale. That means, so screw gauge is like this. So like this, and then you have a circular scale. Okay, and what it says is, uh, so when you move 1 mm on the main scale, when you move 100 when you rotate 100 divisions on this circular scale, you move 1 mm on the main scale. Okay, so there is a so let me just write. So main scale reading is given 2 mm. Okay, and so circular scale reading CSR is given 45 division. So what will the diameter of the wire? The diameter is 2 mm plus 45 divisions, right? 45 divisions on circular scale, but we have to find it in mm, right? Yeah, nice calculation. Okay, so first we have to find the least count. What is the least count of this screw gauge? So in this case, the least count is given by, I'll just write the formula, pitch by number of divisions. Okay, so what is this pitch? So you must have studied electromagnetic waves in your, in electrodynamics. So there also you must have seen that when there is a electric and magnetic field applied to a charged particle, it at some, at an angle, when a charged particle enters a magnetic field at some angle, it start going into a spiral like this, and the distance between the two spiral is called the pitch, right? Something like that. So in that way you can understand what pitch is. So when you rotate this screw gauge, okay, uh, over full rotation, whatever the distance is moved on the linear scale, that is the pitch. And this is given here that 1 mm is the pitch when you go full rotation on the circular scale. Okay, so, and number of division is 100, sorry, 100. So the least count is 0.01 mm. No, this least count is the same that we derived here. Okay, it is the same. Just is just that the method of calculating this least count is same. Okay, is different, little different, but it means the same thing. You can think about it later. Okay, try to correlate this least count that we calculated here and this least count. It is the same thing that we have calculated. Okay, so we have found the least count, and so the diameter will be just 2 mm. uh, 2 mm plus 45 into 0.01 mm, which is 2.45 mm. Okay, so yeah, someone has answered it already, so it's fine. Thank you. Anyone has any doubt? If not, then okay, let's go to the next slide. So, okay, here there is a long statement, so I'll read it. The density of a solid ball is to be determined in an experiment. The diameter of the ball is measured with a screw gauge, and whose pitch is 0.5 mm, and there are 50 divisions on the circular scale. The reading on the main scale is 2.5 mm, and that on the circular scale is 20 divisions. If the measured mass of the ball has a percentage error of 2%, the percentage error in the density is. Okay, so this is a long question, so let's go bit by bit. So first let's write the formula for density. So just mass by volume, mass by 4 by 3 pi r cube. Okay, now we have to find the percentage error in density D. How do we do that? So one simple thing is we can take log on both sides. Okay, so log of d equal to when you take log of a fraction a by b, it is log a minus log b. So we can use it here. So it will be log m minus log 4 by 3 pi r cube, right? Also, if you have log a into b, it is log a plus log b, right? So here you can take 4 by 3 pi outside, so this is just log m minus log 4 by 3 pi plus log of r cube. Now this I did because this is a constant. So now when you differentiate it with respect to uh, so basically we'll just have a differentiation on both sides. Okay, so that this will get cancelled, this will be 0, this middle term, and what we will find is, so let's do a partial differentiation. So d by d equal to delta m by m. uh, yeah, this will also be negative, by the way. Yeah, this will be 0 because it's constant, and delta r cube by r. So delta r cube will be what? 3r square, right? Wait, yeah. Everything is d by d delta m by m. And for the max, because we want only the magnitude, so we will convert this negative sign into positive, because this is the error and we want to have the maximum error. So for maximum error, this will be positive, and 3r square delta r by r, right? This r would get cancelled by this. So finally you have this. Okay, and you have everything, see, uh, you can calculate the least count. So what will be the least count of the screw gauge? It is pitch, which is given 0.5 mm divided by number of division, which is 50. So pitch is 0.01 mm. Okay, and you since you are using it to calculate uh, the radius of yeah mm, yeah, you're calculating the diameter, that means the radius of the ball. So delta r will be the this error 0.01 mm error. Okay, and you can put everything here. Delta m by m is given, which is 2% error, in the mass. So first you need to multiply by 100 on both all the sides, so that will give you the percentage error. So is equal to 2% plus this value. Okay, so 3 into R, and delta R is sorry, it got cluttered, 0.01 mm, right? And the radius you can find here. So reading is 2.5 mm and then 20 divisions. So again, let me calculate the radius. So radius is 2.5 mm plus 20 into 0.01 mm, which is 2.7 mm, right? So put all these things here, and you will get an error of 3.1% or something. Is it fine? Everyone followed, or did I make it very cluttered? It is simple, right? You just have to uh, calculate you just have to take the log of the formula, and then you have to differentiate it, use the partial differentiation, and you have the value of radius and the error in the radius from the measurement that is given in the problem, right? If anyone has any doubt, they can ask. Is it fine, Vimal? Arpit? Okay, thank you. Okay, so let's move to our next problem. Now, this problem is again related to error in measurement. So, and it's a option choice problem. So I'll ask all of you to give your opinion. So I'll read the question. So Young's modulus, which so what do you all of you know what Young modulus is, right? It is a measure of elasticity. So Young's modulus is measured by Searle's method using this formula. Okay, a wire of length L equal to 2 meter and diameter D equal to 0.5 mm is used. Okay, so basically you have a wire. Okay, its length is L, 2 meter, and it has a diameter of 0.5 mm. For a load, so what now we are doing is we are putting a load on this wire like this. Okay, for a load of mass 2.5 kg, an extension of, so this when you put a load, this wire will stretch a little. Okay, and this extension is 0.25 mm. Okay, in the length of the wire. No, quantities D and L are measured using a screw gauge. So you are using a screw gauge to measure these lengths, this diameter and the length extension length, and a micrometer. So micrometer is similar to a screw gauge. They have the same pitch, so their pitch is same, which is 0.5 mm, and the number of division on the circular scale is also same, which is 100. Now the question is the contribution to the maximum probable error of the measurement of y is due to what? Error in the measurements of D and L are same, or it is twice in the measurement of D is twice that due to the error in measurement of L, or the error in measurement of L is twice due to the error in measurement of D, or the error in the measurement of D is 4 times that due to the error in measurement of L. So what do you guys think? So this is the formula. Okay, and you are measuring, so all of these are constant, this is constant, this is, these two you are measuring, L and D. Okay, so what do you think will contribute to the error more, L or D? Anyone? Without doing anything, can anyone tell me? Which will contribute more? L? Okay. Alekhya said L. So Alekhya said option C, which is L is twice than due to the error in measurement in D. Anyone else has any opinion? If we write the percentage error in Y, it will have a term. So because this is D square, it will have 2 delta D by D, right? And L will be just L delta L by L. Now what do you think? This is 2 times B. That is measurement in D is twice. Okay, Arpit says this. No. First of all, you have to see the error does not only depend on the error in the measurement, it also depends on the measured value itself, because it's a relative error, it's not a absolute error. So when you put everything here, so suppose, so because here D is what, 2 times L, right? So what happens is, and delta D is equal to delta L, because both have same pitch and same uh, you know uh, circular scale division. So least count is same for both the, so delta L and delta D is same, but your D is twice L, which cancels the 2 in the above, and then you have delta L by L. So, and these two are equal. So both will contribute same. Okay. So this you have to keep in mind. Just because there is a square here, you cannot say that D will contribute more in there. Okay. So this is a trick question. You all guys have been tricked. So the correct answer is option A. Okay, this is fun. Now, yeah, if the pitch changes, yeah, then we can say. So if suppose because here the pitch is same for both the measurement, that's why. If the pitch changes, then anything can happen, right? If the pitch of the suppose the screw gauge is more, then the error will be more, right? So yeah, if the pitch changes, the error will change. But here that is not the case. Any else? Any other question? Okay, not then. This is our second last problem. So I'll read out the question. The diameter of a cylinder is measured using vernier calipers with no zero error. Okay, so there is no zero error. Anyone know what zero error mean? There is no zero error. Anyone can explain what is zero error in the vernier caliper? So I'll I'll I'll, I'll say so. Zero error is the offset uh, exactly coincide with zero. Yeah. So zero error is the offset with the main scale of the vernier scale. Okay. So that is, suppose you have a you have main scale like this. Main scale 0 is here, and if the vernier scale 0 is here, you know, then we'll say that it is the offset. Okay, it's both should coincide initially. If this is the case, then will say there is a positive or negative zero error. Okay, so next question we will see how what is positive and negative zero error. uh, but here in this problem there is no zero error. Okay, now what is the question? It is found that the zero of the vernier scale lies between 4.10 centimeter and 4.15 centimeter of the main scale. So you have this main scale. Okay, here you have 4.10 and here you have 4.15. Okay, and the vernier and the zero of the vernier scale lies between these two. So suppose here your vernier scale lies. Okay, this is the zero of the vernier scale, and the vernier has a least count. So the least count is given 0.005 centimeter. Okay, and it says that the seven division on the vernier scale exactly coincide with the mark on the main scale, but which mark it doesn't say. It just says that seven division on the vernier scale, 1 2 3 4 5 6 7, it coincide with some point on the vernier on the main scale. Okay, and then you have to find the diameter of the cylinder. So diameter is what? Main scale reading, sorry, plus vernier scale reading. Main scale reading is what? 4.10 centimeter, and vernier scale reading is least count into what? 7, right? When it says that 7 divisions on the vernier scale exactly coincide with a mark, it is telling you that 7 division is the vernier scale division, okay, which coincide with some main scale divisions. So in the seventh problem, we had been given the uh, vernier scale division, which was 16. Sorry, this was, so in the seventh problem, what was given? So it was given that the 20 divisions of vernier scale coincide with the 16 division on the main scale. Okay, but here what we have given is, we have given the least count and how many of division coincide with some division on the main scale. Okay, so so this is just wait, just one information is missing, and because least count is sorry, least count is given by main scale division by vernier scale division, and so main scale division we don't know, so it is x. Vernier scale division is given 7. Least count is given 0.005 centimeter. So x is what? 0.005 into 7. This is the this value. So we can just put it here, and the answer is 4.135 centimeter. So did you guys understand what this question? It is the same thing, but just one information was missing. Okay. Anyone has any doubt here? Okay. If no, then let's move forward. So this is the last problem. Uh, yeah, why main scale reading is taken as 4.10? It is given here, right? So, that the vernier scale lies between 4.10 and 4.15. So we have from main scale we have measured up to 4.10. This distance we don't know, right? This distance we don't know, and that we have found using this formula. Okay, up to 4.10 we know precisely that the because the vernier scale, the zero of the vernier scale lies at somewhere between that. Okay, did you get it? Okay, thank you. Okay, this is the last problem. So now here you will understand the concept of zero error in more detail. So okay, I'll first read out the problem. So what it says is, one full turns of the circular scale of a screw gauge cover a distance of 0.5 mm on its main scale. That is, pitch is given, right? Pitch is 0.5 mm. The total number of division on circular scale is 50, right? So total number of division is given 50. Uh, Further, it is found that the screw gauge has a zero error of minus 0.02 mm. So zero error, it is given as minus 0.02 mm. I'll tell you what this minus sign means. Why it is in negative. Okay. While measuring the diameter of a thin wire, a student notes main scale reading of 4 mm and the number of circular scale division in line with the main scale is 37. Okay, diameter of the wire. So main scale reading is given 4 mm. Okay, circular scale reading is 37 mm. Sorry, 37. Uh, so diameter is what? Diameter is main scale reading plus circular scale reading minus zero error. So always remember, we always subtract the zero error. Okay, we always subtract the zero error from whatever we are measuring. Okay, now let's put everything. So 4 mm is the main scale reading plus circular scale reading will be what? So we have 37 into least count and then minus of minus 0.02 mm, right? So putting everything here, so least count is 0.5 by 50. You will get what? You will get 0.01 mm, right? Yeah, thank you. So it will be 0.37 mm and minus minus will be plus 0.02 mm, right? So total diameter will be 4.39 mm. Now this is the answer. Okay, now let me now tell me why this zero error was given as negative. What does it mean? Does it mean negative zero error, positive zero error? What does it mean? Anyone? Positive error. Okay. Anyone else? Why we add LC? No, we don't add. We have multiplied with the circular scale reading to get the uh, Bimal says negative error. Okay. One Lekhya says positive error. Bimal says. Anyone else has any opinion? So Mahalakshmi, we didn't add the list count. We we found the list count here using the formula for pitch and the number of divisions. So list count is pitch divided by number of division, which is 0.5 by 50, 0.01 mm. Okay, so we multiplied our number of division that was on the circular scale, which is 37, into our list count. So that gives us the circular scale reading in mm. Okay, now this zero error, to find out whether it is a positive error and a negative error, let us do let us draw some pictures. Okay, so first I'll define what positive and negative error, zero error means. So a negative zero error always underestimate the measured value. Okay, and positive zero error overestimate the measured value. This is the definition, simple definition. Negative error will underestimate. So that means this error is a negative error. Okay, because it is underestimating. That's why we finally get a addition, because when we take it negative, get positive. If it would have been a positive error, that means our measured value is overestimated. Then this will be positive and you will get a negative sign, right? So overestimation get cancelled. You understood? So this is the concept. Let me yeah, let me again explain this using a diagram. So this is a screw gauge, right? Screw gauge like this. Suppose this is the main scale here, 0. Okay, and this is the circular scale. 0 0 is coinciding, then you have 5, 10, and here you have 45, and so on. If it is coinciding, this is zero, no zero error, right? Now if there is a scenario like this, and the circular scale reading, the 0 of the circular scale is here, and then you have 5, 10, 45. What would you call it? Anyone? Is it a negative or positive error? Positive, yeah. Thank you. It's a positive error. Okay, and if you have something like this, zero start from here, 45, 5, then this is a negative error. This will overestimate your results. Whatever you will measure more using this vernier caliper, and this will underestimate your result. Whatever you will measure less. So when you subtract the zero error, if you have a positive error, this quantity will be given in positive, so that will So finally you will subtract from your actual measurement, okay, the zero error. So the overestimation get cancelled. And when you have a negative error, you will subtract it with another negative, so that will be positive, and so the underestimation get cancelled when you have a negative error and when you subtract it like this. So in this problem we had a negative error of minus 0.02 mm. So that's why at the end you get a addition sign, so the underestimation got cancelled. I hope you understand clearly, right, everyone? Thank you. Mhm. So I think just four of you are here. Okay. Okay. Can you guys mute and introduce yourself? Like, where are you studying and what are you studying? So that we will get to know each other. If you are comfortable, otherwise it's okay. So I'll first introduce myself. So sorry, I already have introduced myself. So I'll tell little bit more about myself. So I am a fourth year PhD student at IIT Madras. Okay, I work in the area of high energy physics. Uh, so in collaboration with CMS experiment at CERN, and we study the collision of two heavy nuclei like lead nuclei or gold nuclei, and we study the properties of uh, the quark gluon plasma that get formed in those collisions. So this is what I do, and also I would like to know what you guys are studying and what you guys are planning to do in future. So yeah. It will be great if you can speak up by unmuting. Otherwise, in the chat also you can write. So Arpit wrote, I have completed my post graduation and qualified MH set examination and working as CHB lecturer in Navira Mahavidyalaya, Kattur. Okay, thank you. So, do you find this course helpful? Uh, because it's a very basic course. Uh, okay. Alekhya said he's working in Geetam College lab technician. Okay, thank you. Arpit says it's pretty helpful as it covers most of the practicals that we conduct at UZ. Yeah, yeah, these are mainly the concepts of UZ level. So yeah, this can be helpful to refresh your memory and help you in conducting the experiments. Okay, if no one else wants to introduce, then I guess this is the last problem. And thank you for joining. We will meet again next time, same on the same day, Saturday, here. the next. And yeah, like I promised, I will uh, put I'll put the links of the Google Drive in the chat. Okay, so just wait a minute. Yeah, Arpit, there will be another session on Tuesday. Yeah, 30th January, I think. And that will be conducted by another teaching assistant, not by me. I'll be here only on Saturdays, okay? And I'll upload this slide on this Google Drive link that I have shared. So I'll do that in a day or two. You can find it there. Okay, so that's all. Anything else you want to ask? Thank you. Yeah, I'd appreciate if you guys can next time unmute yourself and speak to me directly. That will be very good. Otherwise, it's fine. So, okay. Thank you. If you don't have any question, then thank you for joining. See you again next time. Okay. Bye.